Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called Counterpart and it's by Matt Trussell. And here are the rules. Normal Sudoku rules apply, which means fill every row, column, and box with the digits 1 through 9 without repeats. We also have a new rule set, which is called equal split lines, where dots split lines into segments with equal sums. Digits may repeat on lines, but not within a segment. Different lines may have different sums. So, if you're familiar with region sum lines, this is essentially similar to a region sum line, except that instead of the box borders breaking the line into segments, it's dots that break the line into segments. So all the segments on the same line must sum up to an equal sum, which is why they're called equal split lines. So, for example, these two digits must add up to what these two digits must add up to. Along a longer one, these two digits must add up to what these 5 digits must add up to, which must add up to what these 2 digits add up to. But again, you cannot have repeats within a segment. So you can never have in the segment something along the lines of, I don't know, 1, 2, 3, 1, 2, 1. This is not valid as a segment because there are 2 repeats, in fact, on this segment, which is not allowed. Again, you can have repeats on the line, but not within a segment. And those are all the rules. If you'd like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, the first thing that I see, well, actually, there's 2 things that really stick out to me. One is this long equal split line. Again, like I said, these 2 digits must equal these 5 digits, which must equal these 2 digits. Similarly, there's another equal split line where these 2 digits equal these 5 digits, which equals these 2 digits. Well, the problem is the minimum these 5 digits can be, since there are no repeats allowed on a segment, is 1, 2, 3, 4, and 5. That means these 2 digits must add up to at least 15. But these 2 digits must add up to at least 15. If you know you have 4 digits trying to add up to 30, which is 15 times 15 plus 15, the only combination you can have is 6, 7, 8, and 9. And since they both have to add up to 15 at least, you can never have one adding up to more than 15, right? If you try to have 15 and 16, say, those 4 digits would have to add up to 31, which you cannot do without repeats in normal Sudoku, right? Because the maximum is 6, 7, 8, and 9. And since they're in the same box, there cannot be repeats. Therefore, these 2 sums must add up to 15. Therefore, this must be adding up to 15 for these 5 digits, which makes these 5 digits 1, 2, 3, 4, 5. And these 5 digits 1, 2, 3, 4, 5. These have to be 6, 7, 8, 9. And these have to be 6, 7, 8, 9, as do these. These are 6, 7, 8, 9. These are 6, 7, 8, 9, because it adds up with 6 and 9, 7 and 8, right? Therefore, and then we also have another equal split line, where basically we have 1 digit must add up to the same sum as 3 unique digits. And that's 3 unique digits twice, interestingly enough. What does that mean? That means this is at least 6, 7, 8, 9. This is at least 6, 7, 8, 9. But if this were 6 or 7, well, okay, if this one specifically was 6 or 7, then these 3 digits would have to be the same exact set. It would be either 1, 2, 3 or 1, 2, 4. And actually, what we find out is, if you take a look at this, if we try to have these add up to anything less than 9, what 3 digits can be here? Well, you can have 1, 2, 3, 1, 2, 4, 1, 2, 5, or 1, 3, 4. But then the problem is, in the row, we would have 6 cells which require the 5 digits from 1 through 5, which is not allowed, right? How do you fill out 6 cells with 5 digits? You can't. So you need a 6th digit to be able to add to this digit. Well, what happens? What do we add? We can add 1, 2, and 6 to add up to 9. So this must be 9. This is 1, 2, and 6, which means we cannot have a 1, 2, or 6 in the rest of the row or the rest of this box. So this cannot be 1 or 2. This becomes a 3, 4, 5 triplet. This can't be 6, so this is 7, 8, or 9, which means this can't be 9 because these two add up to 15. This can't be 6. This can't be 6 or 9 because the 9 is already here. So this must be a 7, 8 pair, which forces this to be 6, 9 pair here, because we have a 7, 8 pair in the box, which eliminates 7 and 8 in the rest of the box. This can't be 1, 2. We have a 3, 4, 5 triplet now on this equal split line, which eliminates 3, 4, and 5 in the rest of the segment. So this can't be 3, 4, 5. Therefore, we have a 1, 2, 1, 2 pair here. This cannot be 9, so this can't be 6. We have a 3, 4, 5 triplet in this box, which means the rest of the box contains not a 3, 4, 5, and it can't be 1, 2, or 6, so it must be 7, 8, or 9. We have 1, 2, 3, 4, 5, 6 triplets in row 6, which eliminates 1, 2, 3, 4, 1 through 6, so this must be 7, 8, or 9 also. Therefore, where is the 9 in row 6? It has to be one of these two cells, which means this cannot be 9. Which means this set of 3 digits must require a 1. Well, where could the 1 be? Can't be here because of the 1, 2 pair in the box, so it has to be here. So this is a 1. This can no longer be 2. What's the minimum this could be? 3 and 4. So this has to be 1, 3, 4 here. Which means this adds up to 8. So this is 8. This requires a 1. So one of these is a 1, right? Because you have to have 1, 2, 5 or 1, 3, 4 adding up to 8 for 3 digits. Therefore, this can't be 1. This must be a 2. So this also has to be 1, 3, or 4 adding up to 8. This must be a 1. These can't be 8. This can't be a 7, 8 pair, so it must be specifically 6 and 9. So this is 6, this is 9, which forces this to be 7. We have in this box a 3, 4 pair, which eliminates 3 and 4 in the rest of the box. So this must be a 5, and this must be a 6. Since this is 6, this can't be 6, so this is 9, which makes that a 6. This can't be 8, so since this can't be 8, and this can't be 8, this is a 7, 9 pair in this box, which eliminates 7 and 9 in the rest of the box. So this must be an 8 then. This again can't be 3, 4, 5 because of the 3, 4, 5 on the same segment. This is a 3, 4 pair, which eliminates 3 and 4 in the rest of the row. So therefore, this can't be 3 or 4. So this is 5, which means this can't be 3 or 4. These can't be 5. This can't be 8 anymore, which makes that 7, which makes that 8. The last remaining digit in the middle box is a 5. Okay. These 3 cells must add up to 9. But it cannot be specifically 1, 2, 6. So this can't be 7 here, because if this were 7, this would have to be 8, but that's not possible to add up to 15. These two digits add up to 8, and you can't have 1, 7, and you can't have 3, 5, so it must be 2 and 6. This can't be 6, so this must be 2, which makes this a 6. These three digits cannot be 1, 2, and 6. It has to be either 1, 3, 5 or 2, 3, 4. Because if it's 1, 2, 6, it eliminates all possibilities here. If it's 2, 3, 4, it eliminates all possibilities here also. So this must be specifically 1, 3, and 5. These two digits add up to 9 without 1, 3, or 5. Well, that eliminates 1, 8, 3, 6, and 4, 5, which leaves only 2 and 7. So these are both 2 and 7 here to add up to 9. This cannot be 3, 6 adding up to 9. It could be 1 and 8. It could be 2, 7. And it could be 5 here and 4 here. This cannot be 1 because of the 1, 3, 5 triplet in the column. So this has to be 2 or 6. This can't be 3 because of the 1, 3, 5 triplet in the column. So this must be 4, which makes this a 3. This can't be 1. These two digits add up to 8. So it's either 2, 6 or it's 3, 5. Well, this can't be 5, that can't be 3 then. Let's see, what else do we have? The remaining digits here are 5 and 7. Because we have a 1, 3, 4 triplet. The remaining digits here is kind of varied. It could be 2, 6, 7, 8, and 9. This can't be 2 or 6 because of the 6, 2 here. The 1 in this box has to be, or in column 3, has to be one of those 3 cells. This is a 2, 7 pair in row 9, which eliminates 2 and 7 in the rest of the row. Therefore, this must be 5, which makes that a 7. This can no longer be 5. The rest of the cells in this bottom right box has to be 4, 6, 8, and 9. So let's pencil them in. This can't be 6 or 9, so this must be 4, 8. This can't be 8 because of that 8, so this must be 4, which makes that an 8. That eliminates possibilities of 4, 5, and 1, 8 on these two cells adding up to 9. So therefore, these must be 2 or 7. This has to be a 6, 9 pair because those are the only digits remaining in the box. 9 has to be here, which means 9 has to be one of these two cells. Okay, the remaining digits in row 7 have to be 1, 3, and 5. This can't be 5, and this can't be 1. Okay, 8 has to be here. 8 is one of those 3. 2, 7. One of these is 9. One of these two must be a 6. What else do we have? Okay, the remaining digits here are 5, 7, 8, 9. Let's just fill those in just to see what we have. This can't be 7. This can't be 5. Okay. 2 has to be, cannot be here. Where is 2 in column 2? Can't be here because of the 2, 7 pair. Can't be any of these because of the 2s in the same column, so this must be a 2. Okay, so that's interesting. If this is 9, this can only add up to the same digit if this is 8 and this is 1. But this can't be 1, so this can never be 9, right? If this were 9 and 3, obviously this is too big then for this, because 2 and 10 would have to add up to 9 and 3, or 9 and greater. So this can never be 9, which means this is a 9 here, which means this can't be 9. We now have a 5-8 pair in column 2, which eliminates 5 and 8 in the rest of the column. This must be a 3, which makes this a 1. These can't be 1. This can't be 1 or 3, so this must be 5, which means this can't be 5. This 3 means this can't be 3, so this is a 4, which makes this a 3. These can no longer be 8 here. The remaining digits here are 4 and 8. And to add up to 11, which is what 2 and 9 adds up to, this must be 3 or 7 here. But it can't be 7 because of the 2-7 pair in the box, so this has to be 3 and 8, which makes this a 4. This 3 means this can't be 3, so this is 1, which makes that a 3. This 3 means this can't be 3, so this is 4, which makes that a 3. The remaining digits here are 4 and 6. The remaining digits in row 8 are 1, 5, and 8. This can't be 1 because of this 1. This can't be 5. This can't be 8. Okay. What else do we have? One of these digits is 5 or 6. This is 5 or 8, and this is 6 or 8, which means that one of these is 5 or 6. We have another one which requires a 5 or 8. We have another one which requires a 6 or 8. So we have 3 cells which require the digits 5, 6, and 8. So the remaining digits can never be 5, 6, or 8 in the same row. Cannot be 1. It could be 2, 3, 4, no 5, 6. It could be 7, no 8. It could be 9. This cannot be 4. This cannot be 3 here. And that's all we know for now. Remaining digits here in column 4 are 2, 5, 7, and 8. This can't be 2. What else do we have? Where is the 5 in column 8? Cannot be here. Cannot be here. Can't be here. Again, because one of these requires a 5, 6. One of these requires 5, 8, and this requires 6 or 8. Therefore, a 5 must be one of these cells. Well, what does that add up to? I'm not really sure. It cannot be 1 and 5 here, because if this is 1 and 5, this would have to be some combination of 2 and 4. But 2 is not allowed in the same row. So this cannot be 1 and 5. Maybe it's 2 and 5. That's a lot. Okay, so there's a lot of possibilities here. Oh, this can't be 3 because of this 3. Well, that helps a lot. So therefore, this has to be a 2, 6 pair, which eliminates 2 and 6 in the rest of the row. So this can't be 6 anymore. That makes this an 8. This can't be an 8 anymore, so that's a 5, which makes that an 8. This can't be 8 here. None of these are 8. This 8 must add up with 7 to add up to 15. So this is 7, which makes this a 9. Therefore, we have a 2 or 6 here. This can't be 7 anymore, so this is 9. None of these can be 9. These can't be 2 either. Where is the 9 in row 3? it only can be here. So this is 9, which makes that 7. This can't be 7. This can't be 2 because of the 2, 6 pair in the box. So this can't be 2, which makes that a 5. That 5 means this has to be 8. This can't be 5 or 8, so this must be a 7, which makes this a 2, which makes that a 7. This 8 makes that a 1, which makes that a 5. This 1 makes that a 2, which makes that a 1. This 2 makes that a 6, which makes that a 2. This 6 makes that a 4, which makes that a 6. The remaining digits in column 5 are 8 and 9, but this can't be 9, so this must be 8, which makes that 9. The remaining digits in column 6 have to be 3 and 4. Okay. This can't be 9 because of the 9 here, so this must be 6, which makes this 9. This can no longer be 6 because of this 6. The remaining digits in row 1 have to be 1, 3, 4, and 5, but 5 cannot be here, so this must be a 5. This has to be 1, 3, and 4, but if this is 1, it doesn't add up to any digit that 5 can add. It doesn't add up to any sum with 3 or 4 that 5 can add up to, so this has to specifically be a 3, 4, 3, 4 pair to add up to 7, so 5 must add up with 2 to add up to 7. Therefore, this can't be 2, which makes that a 6. This 6 means this can't be 6, so this is 2, which makes that a 1, which makes that a 6. This 2 means this can't be 2, so this is 7, which makes that a 2. This 7 means this can't be 7, so this is 4, which makes this a 3, which makes that a 7. This 4 also makes this a 3, so none of these can be 3. And this 3 makes this a 4, which makes that 3. This 4 makes this a 1, which makes that a 4, and we're left with a 1. And that's how you solve it. Pretty interesting use of the equal split lines. Trying to think of a way that... I don't know. I just basically solved what I saw available. Yeah, oftentimes with these combinations which have to add up to each other, you'll oftentimes find various restrictions, particularly having 5 digits adding up to the same that 2 unique digits add up to, and 3 unique digits adding up to 1 unique digit. Those are fairly common things that you'll find in these equations. Like if you have arrows which add up to another, to a circle, you'll often see 3 cells adding up to 1 cell. So this is a very common pattern that we see. Similarly, having 5 cells add up to 2 cells. That's very common in region sum lines, and I would assume it's also fairly common in equal split lines too. So be on the lookout for those to help you restrict your possibilities in Sudokus. Anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.